The following problem is a system of linear inequalities. To solve this, we have to graph each linear inequality separately. And to do this, you have to pick a method of graphing. There are three main methods, using the slope-intercept method, which is what I'm going to use in the first one, using the x and y intercept, which we'll use on the second one, and then just making a table of values. So in this first one, we use the slope-intercept. So we identify, because it's already solved for y, we identify the slope as negative 3 over 1. Always write slope as a fraction. And then our y-intercept we identify as 4. That's b. And so we go over, remember when you're doing this, you always plot the y-intercept first, which is 4. And then remember it's rise over run, so you're going to go down negative 3, because that's our rise. So it's down because it's negative, and then to the right 1. And then you're going to repeat that process from the new point, down negative 3 over 1, and just do that a few times. Notice that my line is dotted. Remember, whenever it's a less than or a greater than, then it's a dotted line. It doesn't become solid unless it's equal to. The last step is to check to see which side you're going to shade on. I always check a point, and I'm checking the point 0, 0 to see if it's true. When you put in 0, 0, you end up with 0 greater than 4, which is not true. That means you're going to shade the other side of the line, right? On the left side is 0, 0. That was false, so that means all the points are false. On the right side is then must be true. And notice how I'm shading in a specific direction. That can help you. What I can do with my program I have here, I can actually change the color, which it's nice to have colored pencils to do these problems, because we're going to have to put them on the same graph. So I'm going to change to red. On this particular one, I'm going to use the x and y-intercept method to graph. When you do this, you put in 0 for y to get the x-intercept, and then you put in 0 for x to get the y-intercept. So start by putting in 0 for y. That leaves you with 2x greater than or equal to 12. Divide both sides by 2, and you end up with x greater than or equal to 6. So the x coordinate of the x-intercept is 6. Put 0 in for x, and you get essentially 3y greater than or equal to 12. Divide both sides by 3, and the y-intercept is 4. Now graph these 2 points, and if you notice it's going to be right dab in the middle of that other graph. So graph 6 over 0 up for the x-intercept, and then 0 over 4 up for the y-intercept. And then you got to draw on the line. Now notice this is an equal to problem. It's greater than or equal to. Thus our line has to be a solid line. So you want to draw in a nice solid line before you get going. Now we're going to decide to shade it. Well, the way we decide to shade it is again by picking a point. 0, 0 is always the easiest if it's possible. So put in 0, 0. Well, that's just going to give you 2 times 0 plus 3 times 0, which is 0 plus 0. And we want to see, is 0 plus 0 greater than 12? No, absolutely not. 0 is not greater than 12. Thus you shade above the line instead of below, because 0, 0 is below, and that was false. So you must shade above it. And your answer to this is all the points they have in common. What you need to remember is each one of those solutions are all the points that solve that particular linear equation. The blue solves the first equation, the red solves the second. So we want to find the ones that solve both, and so that's where they overlap each other. So I'm going to go ahead and get a different color out and then shade that region in to indicate that really dark region, either you shade darker or use a darker colored pencil or whatever, that shaded dark region is the solution to our inequality. Every point in that shaded region makes both of those inequalities true, and that's what you need to know.